Most people picture frontier families huddled around massive, crackling fires, burning through endless piles of wood to survive those brutal prairie winters. But that romantic image is completely wrong. The real survival trick that kept settlers alive through nights that dropped to 40 below had nothing to do with building bigger fires. It was a three-part heat management system so clever that it outperformed our modern heating methods using nothing but rocks, ash, and basic physics. Here's what actually happened in those frontier cabins. While you were burning through your entire wood supply trying to heat the air, smart frontiersmen were capturing heat, storing it, and delivering it exactly where their bodies needed it most. They turned their bedrolls into thermal fortresses, and their fires into all-night heat engines. And the centerpiece of this system was a technique so simple that you can use it tonight if your power goes out. Give me the new few minutes, and I'll show you how settlers conquered the deadliest winters in American history using a method that modern survival experts have completely forgotten. That cozy log cabin picture in your head? Forget it. Frontier cabins were drafty death traps designed by necessity, not comfort. The gaps between those hand-hewn logs were sealed with whatever settlers could find: mud, moss, clay, and all of it cracked when winter hit. Every cabin became a sieve, letting knife-edge drafts slice through at ankle level, knee level, and right across your face while you slept. But the drafts weren't even the worst part. The floor was packed earth or rough planks with gaps you could lose a finger through. That ground beneath their feet was a massive heat sink, constantly pulling warmth away from their bodies through direct conduction. Every calorie of body heat they generated got sucked straight down into the frozen earth. And here's the killer detail that Hollywood always gets wrong. Their fireplaces were heat destroyers, not heat creators. These massive stone chimneys were built for cooking and light, not efficiency. They pulled warm air from the cabin and shot it straight up into the night sky. The bigger the fire, the more warm air got vacuumed out of their living space. So frontier families faced a three-way attack: convection from the drafts stealing their warm air, conduction through the floor draining their body heat, and radiation loss through poorly managed fires. The cold wasn't just outside trying to get in, it was inside, actively working against them through the basic laws of physics. The families who survived learned to fight back with physics. They built a system that tackled each type of heat loss with a specific countermeasure. And it started with doing something to their fire that seems completely backwards. They learned how to put it to sleep. The difference between a dead family and a living one often came down to a single skill: learning how to put your fire to sleep without killing it. Anyone could build a roaring blaze, but real frontiersmen knew the most important moment wasn't lighting the fire. It was ending it for the night. They called it banking, and it transformed their fireplace from a heat-wasting monster into an all-night thermal engine. Here's how it worked. After cooking dinner and warming the cabin, they'd let their fire burn down to a thick bed of glowing coals. Not flames. Flames meant wasted heat shooting up the chimney. They wanted those deep red embers that radiated steady warmth without the light show. Next came the crucial step. They'd push those coals into a compact pile against the back of the fireplace and bury them completely under a thick blanket of ash from previous fires. Wood ash is nature's perfect insulator. It cuts off just enough oxygen to prevent the coals from bursting into flames, but leaves enough to keep them smoldering steadily for 8 to 10 hours. Sometimes they'd place one massive log, usually dense hardwood like oak or hickory, preferably still a bit green, directly on top of the coals before covering everything with ash. That log wouldn't burn. It would smolder like a massive charcoal briquette, releasing heat so slowly that it lasted until dawn. This wasn't just about conserving firewood, though that mattered when every log meant hours of dangerous work with an axe. Banking eliminated the deadly risk of sparks igniting their wooden homes while they slept. More importantly, it provided exactly what they needed: steady, controlled, radiant heat that warmed their bodies without heating empty air. But the banked fire was just the foundation. The genius of the frontier system was what they did next. They learned how to steal that heat and carry it directly into their beds using the world's first portable radiator. The banked fire solved half the problem by providing steady heat without burning down the cabin. But radiant warmth from across the room couldn't penetrate 3 wool blankets to reach your bones. For that, frontier families needed to bring the fire's heat directly into their bedrolls with them. Their solution was brilliant. They turned ordinary stones into thermal batteries. Dense river rocks became their portable radiators. Not just any stone would work. Porous rocks like sandstone held moisture that could turn to steam and explode when heated. Smart settlers learned to choose smooth, solid stones that could absorb massive amounts of heat without cracking. These rocks were placed near their banked fire throughout the evening, slowly soaking up thermal energy like sponges. Before bed, they'd fish out a stone using long-handled tools or thick leather gloves. The critical step was wrapping it immediately in cloth, hide, or spare wool. This wasn't just about preventing burns, though a bare heated stone could scar you badly. The wrapping controlled the heat release, turning the stone from a dangerous hotspot into a gentle, steady warmer that could radiate comfort for hours. They'd slip this wrapped heat source into their bedroll several minutes before climbing in, pre-warming the entire sleeping space from the inside out. The stone worked through direct conduction, transferring its stored energy to everything it touched: blankets, furs, and eventually their bodies. Unlike the fireplace that heated air, the stone heated matter directly. The physics were perfect. Stone has excellent thermal mass, meaning it can absorb enormous amounts of heat energy and release it slowly over time. While their banked fire might keep the cabin just above freezing, their personal heat battery could maintain bedroll temperatures in the 70s all night long. But even this ingenious heat delivery system would fail without the final component, turning their bedding into an insulated fortress that could trap every precious degree and hold it against their bodies until dawn. The hot stone delivered the heat, but without proper insulation, that warmth would escape into the frozen air within minutes. Frontier families understood that their bedroll wasn't just bedding. It was a carefully engineered heat trap designed to capture their body warmth and their stone's energy, then hold both against the relentless cold trying to steal it away. The system started from the ground up, literally. Nobody slept directly on those heat-sucking dirt floors or rough wooden planks. The first layer was always a thick mattress of whatever insulating material they could gather: pine boughs, dried prairie grass, corn husks, or straw. This created a crucial air pocket between their bodies and the frozen ground beneath. Air is an excellent insulator when it's trapped and still, and this foundation layer prevented conductive heat loss that could drain their warmth faster than they could produce it. On top of this insulating base came the bedding layers, each serving a specific thermal purpose. Wool blankets formed the core of their system, because wool possessed an almost magical property. It insulated even when damp, which mattered in those perpetually humid frontier cabins. The crimped structure of wool fibers trapped thousands of tiny air pockets that held warm air close to their bodies. But the ultimate insulator was the buffalo robe. These massive hides, with their dense hollow shaft fur, created the most effective heat trap available on the frontier. The hide itself blocked wind and drafts, while the thick fur layer trapped enormous volumes of still air. Smart families wore the fur side inward, directly against their other blankets, maximizing the insulating effect where it mattered most. The final piece was positioning and shared resources. Families slept together, combining their body heat to reduce the thermal load on each individual. They built raised sleeping platforms, even just a few inches of elevation, to escape the coldest air that settled near the floor and to further separate themselves from the ground's heat-draining effect. When everything worked together, this insulating cocoon could maintain comfortable temperatures, even when the cabin's interior dropped below freezing. The banked fire provided ambient warmth, the hot stone delivered targeted heat directly into the bedroll, and the layered insulation system trapped it all in a thermal fortress that turned basic frontier materials into a life-saving heat management machine. When every component locked into place, banked fire, heated stones, and insulated bedrolls, Frontier families had assembled a heat management system that could defeat the most vicious prairie winters, using nothing but physics and preparation. This wasn't just survival. It was thermal engineering that put their lives in their own hands, rather than leaving them at the mercy of brutal weather that regularly killed less prepared settlers. The complete system operated like a perfectly coordinated machine. The banked fire served as the base load power plant, maintaining the cabin's ambient temperature just above the point where water would freeze in their drinking buckets. Those smoldering coals under their blanket of ash radiated steady warmth for 8 to 10 hours without any human intervention, eliminating the deadly choice between freezing or risking a house fire through the night. Meanwhile, their heated stones functioned as targeted heat delivery devices, carrying concentrated thermal energy directly to where their bodies needed it most. These portable radiators bypassed the inefficient process of heating air and delivered warmth through direct conduction, the fastest, most effective method of heat transfer available to human skin. A single properly heated and wrapped stone could maintain bedroll temperatures in the comfortable range, even when the cabin's interior hovered near freezing. The layered bedding system completed the thermal circuit by trapping and holding every precious degree these heat sources provided. The insulating foundation of pine boughs or straw blocked conductive heat loss to the frozen ground, the silent killer that drained body warmth faster than metabolism could replace it. The wool blankets and buffalo robes created multiple dead air spaces that surrounded their bodies with trapped warmed air that couldn't escape to the drafty cabin beyond. But the true genius lay in how these elements reinforced each other. The banked fire's steady, radiant heat meant their stones stayed warm longer. The pre-warmed bedroll reduced the thermal shock that could waste precious body heat. The shared sleeping arrangements multiplied the effective heat output of each person while reducing individual thermal needs. Every component made every other component work better. This integrated approach explains how frontier families regularly survived nights when temperatures plunged to 40 below zero. Conditions that would challenge modern heating systems. They weren't fighting the cold with brute force heat production like we do today. They were managing thermal energy like engineers, capturing it efficiently, storing it effectively, and delivering it precisely where their bodies required it most. The system proved so effective that experienced frontier families could sleep comfortably through blizzards that killed travelers caught unprepared just miles away. While those unfortunate souls burned through entire wood piles trying to heat drafty shelters, smart settlers used a fraction of the fuel to achieve superior results. They had discovered that thermal comfort wasn't about generating more heat. It was about losing less of what they already had. Modern survival experts have largely forgotten these techniques, focusing instead on high-tech gear and energy-intensive solutions that fail when the power grid goes down. But the Frontier system required no external energy, no manufactured components, and no complex maintenance. It worked with materials available in any rural environment and could be implemented by anyone who understood the basic principles of heat transfer and retention. When you strip away the romantic mythology and examine what actually kept people alive during America's harshest winters, you find not primitive endurance but sophisticated thermal management that solved fundamental physics problems using elegant low-tech solutions that worked perfectly every single time. The next time your power goes out on a cold night and you're fumbling with blankets and space heaters, remember what frontier families accomplished with nothing but fire, rocks, and intelligent preparation. They didn't just survive winters that regularly killed their neighbors, they slept comfortably through blizzards that would challenge modern heating systems, using a thermal management approach that our high-tech world has completely abandoned. These weren't primitive people making do with crude methods. They were engineers solving complex heat transfer problems, with elegant low-energy solutions that worked perfectly every time. While we burn through massive amounts of electricity and natural gas trying to heat entire buildings, they focused their thermal energy exactly where human bodies needed it most. Their system required no power grid, no manufactured components, and no complex maintenance, just an understanding of physics and the discipline to execute each step properly. The banked fire technique alone could revolutionize how you think about heating efficiency. Instead of feeding a roaring blaze that sends most of its energy up the chimney, Banking transforms your fireplace into a steady thermal engine that operates all night on a fraction of the fuel. The hot stone method gives you targeted heat delivery that bypasses the inefficient process of warming air to warm your body. And their insulation strategies prove that thermal comfort isn't about generating more heat. It's about losing less of what you already produce. Modern. Survival experts have traded this sophisticated knowledge for expensive gear that fails when you need it most. But the Frontier system worked with materials you can find in any rural environment. River rocks, wood ash, wool blankets, and pine boughs were enough to defeat the deadliest winters in American history when combined with the right techniques. What makes this knowledge even more valuable today is how completely we've forgotten it. Emergency preparedness has become synonymous with stockpiling batteries and generators, but those solutions assume civilization keeps functioning enough to manufacture and deliver the components. The Frontier approach assumed nothing except your ability to gather natural materials and apply basic thermal principles that never change. Their thermal management systems solved the same problems we face during power outages, but with solutions that couldn't be disrupted by failing infrastructure. No supply chain could cut off their access to heated stones. No utility company could shut down their banked fire system. No manufacturer could stop producing the pine boughs and wool blankets that formed their insulating fortress. This represents something larger than just cold weather survival techniques. These methods prove that sophisticated solutions don't require complex technology. They require deep understanding of fundamental principles and the skill to apply them systematically. Frontier families succeeded because they treated thermal management as a complete system where every component reinforced every other component, rather than looking for single solution quick fixes. When you examine what actually kept people alive during America's harshest winters, you discover that the old ways weren't just simpler, they were often smarter. While we've gained convenience and automation, we've lost the robust, self-reliant approaches that worked independently of everything except human knowledge and natural materials. The Frontier heat management system stands as proof that real security comes not from depending on complex external systems, but from understanding timeless principles well enough to implement them with whatever resources you can gather. That knowledge can't be shut off, recalled, or made obsolete. And on a cold night when the power fails, it might be the difference between comfort and catastrophe. These forgotten techniques put thermal control back in your hands, where Frontier families knew it belonged. Sometimes the most advanced solution is the one that never stops working.